State the formula representing the equivalence of mass and energy. 1905 was an important year for Einstein. He came up with an explanation of the photoelectric effect, and he also came up with a paper which described, it was called the electrodynamics of moving bodies. It became later to be known as the special theory of relativity. In this same year, he made another paper which discussed the equivalence of mass and energy, the most famous equation in science. The paper was called this. The paper, in German, can be translated as, is the inertia of a body dependent on its energy content. So the faster it goes, the more energy it has. Does it have more mass? And this is related to this equation, E is equal to mc squared. I think you've seen this equation before. Energy can be turned into mass, and mass can be turned into energy. Give an example of the use of this equation. You know already that in nuclear processes, when you have a mass defect, mass can be converted directly into energy. And it can also be in this way. If you give a mass more kinetic energy, you give it you go faster, it will also gain mass. The more energy you give it, the more massive it gets. We need to define the rest mass. There are two words you need to remember when you define the rest mass. It's rest and mass, and you have to think about who is it at rest with respect to. So the rest mass is a mass as measured in a frame of reference where the object is at rest with respect to the observer or the person that is measuring the mass. I marked a paper a couple of years ago where somebody who did very well on this paper described it as the mass of an object which is at rest with respect to whom. Who's deciding what's rest and who's deciding what's moving. So he didn't get the mark, but he wrote a bit of a sarcastic comment about how easy that question was, but he got it wrong. So we have this equation here, the relativistic mass is equal to the rest mass times by the gamma factor. So this could be 1, or it could be 2, it could be 3. So it could be that 1 kilogram, when it's moving very quickly, could actually be weighing 3 kilograms. It could have a mass of 3 kilograms. Okay, this means that others that measure mass, which is moving, will measure a value m, which is greater than its rest mass. And it looks something like this. Okay, this line is a bit wobbly. It's not supposed to do this, but it is asymptotic to c, which is the speed of light. So as you get towards the speed of light, the mass starts to increase very rapidly. Much more rapidly here, and it only starts to increase here. So this is not a good drawing. It looks more like this. This is the mass. Now, let's apply an accelerating force to a non-relativistic situation. As you increase the speed, increase the time, the speed increases, applying a constant force. F is equal to ma. The acceleration will be constant. The speed, the rate of change of speed is constant. However, and it means, however, if that you have, relativistically speaking, what's going to happen then to the speed? It's only as you increase for time with a constant force, it gets closer and closer to c, but will never get there. It becomes more and more difficult to make this mass accelerate because it's getting bigger. And the same with the kinetic energy. Explain why no object can ever attain the speed of light in a vacuum. So this is the speed of light. This is the mass. As the velocity increases, the mass starts to increase and increase. As you approach the speed of light, then the mass increases and gets towards infinity at the speed of light. So as the velocity increases, the mass increases. So it takes more and more energy to make it move faster. As the velocity tends to c, the speed of light, the mass tends to infinity. So you need an infinite amount of energy to make it accelerate. A little question: what is the mass of 1 kilogram When travelling at 99% of the speed of light, remember you need to use the Lorentz factor. By substituting instead of V, you have 0.99c. You will end up with a value for around 7. It will be about 7 kilograms. But you should try that and see if you can get the right answer.